We're back. Alright, so part 2 is 3 is 4, and in 28, use the discriminant, which is the part under the radical in the quadratic formula. You don't really have to necessarily write this out, but I'll write it just to make sure we know what's going on. This is the discriminant, right? Just the part under the radical. So we want to use the discriminant to determine all values of k that would result in the equation x squared minus kx plus 4 equals 0 having equal roots. So we have to think about what would have to happen here to b squared minus 4ac to give us equal roots. The only way you get the same number twice is if you add or subtract 0. So we want all of b squared minus 4ac to equal 0. And our b value is negative k. Our a value is 1. And our c value is 4. So, we did the square there. So it's k squared minus 16 is 0. Factors are k plus 4, k minus 4. It's a difference of perfect squares. So k equals negative 4. K equals positive 4. And you could put those in a solution set or just make it really clear that those are our answers. In 2, the scores of one class on the Unit 2 mathematics test are shown in the table below. Find the population standard deviation of these scores to the nearest tenth. So we want to put those in as two lists. So let's see. We're going to go to Stat, Edit. I'm going to clear these out using clear only. So clear out these two lists, and we'll put in our data. Maybe I'll come down here so I can actually see this. Alright, so I've put in all my data for L1 and L2. Stat calc. Always one var stats for finding mean, standard deviation, and all of that. But in this case, it's a frequency table, so I have to tell it L1, L2, second L1, comma, second L2. Right, I have to tell it to look at it as a frequency table. And that seems pretty good, because the n value is 22, which if you were to add up the frequencies is what we want. So the population standard deviation is this one. This is the sample, which we weren't asked for. We want the population standard deviation. To the nearest tenth, 7.4. So one of the big things there was L1, comma, L2. In 30, we have a massive amount of space, but you really don't need much of it. The sum is negative b over a. The product is c over a. Let me read the question. So find the sum and product of the roots of the equation 5x squared plus 11x minus 3 equals 0. So for the sum, the b value is 11, the a value is 5. That's it for the sum. We would simplify it if it needed to be. And the product is c over a. C is negative 3, and a is again 5. That is it. Right, so knowing these two formulas for sum and product make this a pretty simple question. In number 31, the graph of the equation y equals 1/2 to the x has an asymptote. On the grid below, sketch the graph of y equals 1/2 to the x power and write the equation of this asymptote. So you could do this by hand, or you could do this in the calculator. It's really your call. But I do want to get a table of values and plot them as precisely as I can. And many of these won't fit on the graph. Right, that should be our general shape. The thing to be aware of, though, is it makes it appear as though it hits the x-axis, which it really shouldn't. Because as we can see in the table, it gets closer and closer, but not quite to 0. And and that idea will come together in a minute. So yeah, we'll plot some of these. Negative 3, 8. Negative 2, 4. Negative 1, 2. 0, 1. And now we're going to have to estimate the best we can. 1.5, 2.25, and so on. 3.125. So we want to just show, I'm dealing with kind of a thick marker here, so maybe I'll exaggerate it slightly, but you want to make it clear that you're not hitting the x-axis. Right? So we want to show that we have this value that we're approaching. And that's exactly what an asymptote is. Right? An asymptote is a line that you approach but don't quite hit. You get closer and closer and closer but never touch. And in this case it's the x-axis. We're asked for the equation of this asymptote. All horizontal lines are y equals a constant, and on the x-axis y is always 0. So it's y equals 0. That's the equation of the asymptote. In 32, express 5 radical 3x cubed minus 2 radical 27x cubed in simplest radical form. So the first radical can be broken up. Can't really do much of anything with 3, that goes right in the leftover stack. X cubed, you want the power to be divisible by the root. And if no root is shown, then it's 2. So the most we can divide out is x squared, leaving us with the leftover of x. 27 can be broken up. 9 is a perfect square. 3 is a leftover. And again, x cubed breaks up to x squared and x. So this is 5 times just x, 2 divided by 2, times radical 3x, minus 2, times 3x, square root of 9 is 3, and again 2 divided by 2 is just 1. So it's 5x radical 3x, minus 6x radical 3x. And these are like terms. They have same radicals, and the coefficients have the same variables. So those combine to negative x radical 3x. It's nice if we put a little equal sign throughout. And that's as far as we can go. So in number 33, on the unit circle shown in the diagram below, sketch an angle in standard position whose degree measure is 240 and find the exact value of the sine of 240. Standard position always has an initial ray on the x-axis. And in this case, we're getting to 240, pretty close to 270, so it lands in the third quadrant. And there's our picture. I want to show that it lands definitely between 180 and 270. You don't have to be entirely precise, but that's the main idea. And from there, we want the sine of this angle, 240 degrees. So it's good to know that point, it's left a half, down radical 3 over 2. Right, that's one of our unit circle coordinates. And sine of an angle is the y value. So negative radical 3 over 2. So make sure you brush up on the unit circle. Definitely before the Regents. In 34, two sides of a parallelogram are 24 feet and 30 feet. The measure of the angle between these sides is 57 degrees. Find the area of the parallelogram to the nearest square foot. So 24 feet, 30 feet, and the angle is 57 degrees. So we don't really have a tricky formula for the area of a parallelogram, but we do have one for the area of a triangle. Right? And pretty simply, we could break up this parallelogram into two congruent triangles. We can find the area of one of them using our formula. 1/2, 24, times 30 times the sine of 57 degrees. Since we have two triangles, we could go ahead and double that area. Make sure we're in degree mode. Right, it's 57 degrees. So it's 1/2 24 times 30 times the sine of 57 degrees, and we want that doubled. So about 604 when we round to the nearest foot. And that's an area, so it's square feet. Some people might also notice that, well, 1/2 and 2 could also cancel one another out, so this would give us the same answer. Because you're taking half of it and doubling it, which again, cancel one another out. In 35, you're given a complex fraction, and you're asked to express it in simplest form. Common denominators. If we have common denominators everywhere, we can clear them. And in this case, our LCD is 2D. This one's already got it. This is missing D. This is missing 2. And this is missing 2 as well. All the denominators are 2D. So again, those can clear. So all that's left up top is D minus 8. And down below, 2 plus 3. So D minus 8 all over 5. That's a D. Funny looking D. Alright, 36. The members of a men's club have a choice of wearing black or red vests to their club meetings. A study done over a period of many years determined that the percentage of black vests worn is 60%. If there are 10 men at a club meeting on a given night, what is the probability to the nearest thousandth that at least 8 of the vests worn will be all black? That's the total number of black vests that could be there, anywhere between 0 and 10. We want at least 8, meaning the least it can be is 8, so it could be 8, 9, or 10. This is a Bernoulli problem, or a binomial probability. So of the 10, 8 black vests, or, so plus, of the 10, 9 black vests, or, of the 10, all black vests. This is up here, leaving us with 2 left over, 9 leaving us with 1 left over, 10 leaving us with 0 left over. And 60% is for black vests, leaving us with 40% for red. And that can go in all at once. That's something we can just put in. I think it sometimes is nicer to put it in all at once rather than in steps. And this last bit, we wouldn't really need to put 0.4 raised to the 0 because that's just 1, but it wouldn't hurt if you put it in. Oop, what did I do here? Let's check it out. There we go, we're missing something. So that was 10C9. I left out my 9. So 0.167 to the nearest thousandth, right? 1,000 has 3 zeros, so we want to go as far as 3 places. And it stays put, doesn't round, because the next value is a 2. So 0.167. And you can put 0 in front. Doesn't matter whether or not you do. The thing that really matters is that you have 3 places exactly after the decimal. In 37, find all values of theta that in the interval 0 degrees, less than or equal to theta, less than 360 degrees, that satisfy the equation sine 2 theta is sine theta. We always want to get rid of double angles, and sine 2 theta has only one choice. 2 sine theta, cosine theta, right up top. Right, A's are on the reference sheet, but our problem has theta. So that gets replaced. 2 sine theta, cosine theta equals sine of theta. So we want everything on one side. We'll subtract sine theta. And in this case, we have a GCF of sine theta, leaving us with 2 cosine theta minus 1. And each of those can be set equal to 0. So sine theta is 0. And cosine theta is a half. Zeros and ones I don't want reference angles for. A y value, because it's sine of 0, happens in these 2 spots. 1, 0, negative 1, 0. So this is at 0 degrees. We're not calling it 360 because it's strictly less than 360. And this is 180 degrees. Cosine theta is a half. This is on the right side. And its next value of a half, so with good unit circle knowledge, we could just tell that that's 60 degrees, or cosine inverse of 0.5, or a half. Right? So either way, we find that that's a reference angle of 60 degrees. Which is our first quadrant value. And our third is 360 minus 60. We'll just round those up. We weren't told how we needed to do this, so it would be fine also if you were to move over sine theta to the left side. So sine 2x minus sine of x. We could just graph this. Put y2 is 0. Our window we want from 0 to 360. And probably we could get away with looking up and down 5 or something like that. We can see how it looks. We might want to even look up and down a little bit less than that. Maybe we'll look up and down 3. Might be easier to tell what's going on. So since we weren't told we had to solve this one algebraically, we could solve it graphically and then just calculate all of the intersection points. And that's an example of one of them, right? You could find them all that way. Just make sure, again, you don't include 360 because it's not part of our domain originally. So in 38, the letters of any word can be rearranged. Carol believes that the number of different 9-letter arrangements of the word Tennessee is greater than the number of different 7-letter arrangements of the word Vermont. Is she correct? So Tennessee, let's write that a little larger. So that does have 1, 2, 3, 4, 5, 6, 7, 8, 9. So it would be 9 factorial ways of arranging it. But we have repeated letters. Just one T. We have 1, 2, 3, 4 E's. So 4 factorial. We have 2 N's, 2 factorial, and 2 S's, another 2 factorial. So we could calculate that. So So up top is 9 factorial, which is in math probability, choice 4. Down below, 4 factorial, 4 factorial, 2 factorial. 4, 2, 2 rather. So Tennessee, 3,780 different ways of arranging it. And Vermont, so 1, 2, 3, 4, 5, 6, 7. 7 factorial. Any repetition? 1V, 1E, 1R, 1N. Nope, no repetition anywhere. So 7 factorial, 5,040. That was the total number of arrangements in Vermont. So Carol believed that there were more arrangements of Tennessee, so Carol is wrong. Right, and this is the justification as to why. Right? Your numeric justification is what they're asking for here. Justify your answer. That's been done up top. 39. There's one 6-point question. I think this one was pretty reasonable in this Regents. So in a triangle, 2 sides that measure 60 degrees, or rather 6 centimeters and 10 centimeters, form an angle that measures 80 degrees. Find to the nearest degree the measure of the smallest angle in the triangle. So in order to tell which angle is smallest, we really want to know all 3 sides, because the smallest angle is opposite the shortest side. So first off, I want to know this other side. And I can find that using law of cosines. So x squared is 6 squared plus 10 squared minus 2 times 6 times 10 times the cosine of 80 degrees. And we can pop all that in, making sure once again we're in degree mode. So that's the right side before we've taken the square root. It is nice to show that, because if we do make a mistake later on, at least we have this. And I would just take the square root, so second square root of that answer, second negative, 10.73 and so on. I want to keep all of that, because this isn't my final answer yet. So once I know that, well, now I can tell that the smallest angle is the one opposite 6, because that's definitely the shortest side. So I can use really either law of sines or law of cosines. I'll use law of sines in this case. So we could put sine y over 6 or vice versa. If we put sine y on top, it might be a little bit shorter, but this is fine. We have to use the side we just found, 10.73 and so on, divided by the sine of 80 degrees. And then we'll just cross multiply. 10.73 and so on times the sine of y is 6 times the sine of 80 degrees. We can divide both sides by that 10 value. We'll continue on this page. So if you don't take your Regents with a Sharpie, you probably should have plenty of room. So let's see. 6 sine of 80 divided by that last answer, 0.5506 and so on. So that's all of our sine value. Which would be in the first 2 quadrants. And we'll get the reference angle by taking sine inverse of that decimal. So it's 33.4 and so on degrees. We want nearest whole degree, so it's about 33 degrees, making our second quadrant value, 180 minus 33, we're 147 degrees. But that's too large, because 147 degrees, along with 80, could never be in the same triangle. So it would be more than 180. So it has to be 33 degrees. But you always want to check with law of sines both the first and second quadrant answer. Alright, that is the June 2010 Regents.